The ocean is not a battlefield, it is a ruthless auditor. It does not care about your $800 billion taxpayer-funded budget or the flags fluttering from your mast. It obeys only the cold laws of hydrodynamics and pressure. Deep beneath the rolling waves of the North Atlantic, a threat is lurking. It is a diesel-electric submarine engine cut drifting in the thermal currents, silent and invisible. It has achieved acoustic invisibility, matching its own signature to the ambient decibel level of the ocean floor. It does not carry conventional bombs meant for the surface. It carries a heavyweight guided torpedo, a weapon of surgical finality. Forget the Hollywood imagery of a torpedo slamming into the side of a ship. This weapon is a cold-blooded assassin. It is programmed to dive beneath the keel into the pressurized void under the hull. That is where it detonates. The explosion doesn't just tear through steel, it creates a massive pulsating gas bubble. The rapid expansion and collapse of this bubble lift the ship, then drop it into a momentary vacuum. In a heartbeat, the ocean removes the support from 100,000 tons of American sovereignty. Gravity does the rest of the brutal work, snapping the spine of a $13 billion nuclear monster in half like a dry twig. That is the death of metal, but war also has a biological cost. On the deafening flight deck of a carrier, the line between life and death is roughly the width of a jet exhaust stream. One slip, one gust of wind, or one accidental ejection, and a human body falls into the freezing black water. The moment he hits the waves, rank and honor become meaningless. He is no longer a sailor. He is a 98-degree biological heat source, dropped into a massive heat sink. Seawater conducts heat 25 times faster than air. Thermodynamics will strip the life from his core faster than any bullet. He has 15 minutes, perhaps less, before his biological systems collapse and the ocean claims him. To prevent these two catastrophes, one caused by pressure, the other by temperature, the United States Navy does not bet on massive deck guns or thicker armor. They bet on rotors. They call it the Seahawk. But physics is a zero-sum game. You cannot stuff a submarine hunting data center and a logistics cargo bay into the same finite airframe without making a choice. To survive, the Seahawk platform was forced to evolve in two inverse directions. The engineers were forced to split its soul. One half became a ruthless shield to hunt enemies in the deep. The other became an angel to snatch life from the jaws of the abyss. Welcome to Navy Decoded. Today we are not talking about courage. We are talking about the fragility of power and the engineering required to sustain it. Before we dissect the differences, we must understand the common ground. At a glance, these two helicopters, the Romeo and the Sierra, are identical twins. They share the same gray salt-resistant paint, the same aerodynamic profile, and the same violent heart, the T700 GE401C engine. This twin turboshaft beast screams with 1,900 shaft horsepower, but its true specialty is survival. It features an integrated particle separator that strips salt and sand from the intake, allowing it to breathe the corrosive sea air for thousands of hours without rotting from the inside out. They also share a common brain. The aging, imprecise analog gauges of the past have been purged. In their place are multifunction liquid crystal displays running algorithms that help the pilot manage a tidal wave of battlefield data. But the similarities end there. In war, versatility is the enemy of perfection. You cannot be both a silent assassin and a cargo truck. Sikorsky engineers performed a surgical separation on the S-70 airframe. Look at the MH-60R, the Romeo. The port side sliding door has been deleted, replaced by the pneumatic muscle of the Sonobuoy launch system. The cabin seats are gone, replaced by high-density avionics racks, signal processing units, and miles of fiber optic cables. It is a hunchbacked, cramped monster, a predator obsessed with listening for echoes from the deep. It sacrifices every ounce of comfort for the sake of hearing. Now look at the MH-60S, the Sierra. They did the opposite. They gutted it. They tore open the rib cage with massive sliding doors on both sides. They turned the rear cabin into a void, not because they lacked components, but because that empty space holds hope. That is where the food, the ammunition, and the wounded soldiers go. The Sierra sacrifices sophisticated sensors for the sake of volume. Today we will prove that power does not come from being a generalist. Power comes from absolute specialization. And we must start with the hunter. Why does a mighty surface fleet protected by billions of dollars in radar and sonar fear a tiny diesel submarine? The answer lies in refraction. The ocean is not a uniform pool, it is a thermal layer cake. The sun warms the surface while the deep remains freezing. At the boundary, a thermocline layer forms. When a destroyer blasts active sonar from the surface, the sound waves hit this layer and bend, reflecting upward or deflecting entirely. A submarine only needs to dive below this mirror to become invisible to the surface ships. That is where the Romeo enters the fight. It does not guess, it uses physics to fight physics. The Romeo hovers 50 feet above the white caps and drops the dipping sonar. This is not a mere microphone, it is an acoustic drill. The transducer is lowered on a cable punching through the surface and through the thermocline to the exact depth where the sub is hiding. There it emits a massive active ping. The sound waves slam into the submarine's hull and bounce directly back to the sensor without thermal interference. The Romeo strips away the enemy's cloak of invisibility using pure directed physical force. But the ocean is vast, and the Romeo cannot be everywhere at once. This is why it controls space through a sensor minefield. Using its 25 launch tubes, the pilot seeds the water with sonar buoys, some passive, some active. Data from this network is beamed back to the helicopter's central computer where triangulation algorithms plot the enemy's exact course speed and depth. Even when a submarine tries to breathe, the Romeo is watching. A diesel sub must eventually raise a snorkel to run its generators. In a rough sea, finding a snorkel the size of a soda can is impossible for the human eye, but the Romeo uses the AN/APS-153V multimode radar. This system uses ISAR, inverse synthetic aperture radar algorithms. It uses the target's own motion on the waves to synthesize a high-resolution 2D image, distinguishing between a breaking wave and cold hard metal. Once the target is locked, the kill chain is completed with the drop of a Mark 54 lightweight torpedo. It hits the water, finds the signature and sprints toward the pressure hull. Game over. If the Romeo is the pinnacle of sensors, the MH-60S, the Sierra is the pinnacle of spatial geometry. The Romeo's problem is density. Its rear cabin is a claustrophobic nightmare, choked with server racks and miles of cabling. Fitting a rescue litter in there requires Tetris-level skills and precious time. The Sierra is Sikorsky's answer to the logistics equation. Inheriting the wide airframe of the Black Hawk, it is built on the concept of the void. But an empty box is useless if you cannot load it fast enough. This is where mechanical elegance comes in. Look at the floor. The Sierra deck is not just a slab of metal, it is an integrated flip-over roller system. When cargo is the mission, the crew flips the rollers up. The entire floor becomes an industrial conveyor belt, allowing sailors to slide multi-ton pallets deep into the cabin with a gentle push. When troops are the mission, they flip them flat to create a non-slip surface. It is a micro-level mechanical adaptation, but it dictates the loading efficiency of the entire fleet. Why are the void and this roller floor so critical? Because of a strategic paradox. The nuclear carrier. The A1B reactor allows the ship to steam for 20 years without refueling, but sailors still need to eat. More importantly, jets need bombs. A carrier will run dry of ordnance after just a few weeks of high-intensity combat. At that point, it is just a useless floating airport. The Sierra is the lifeline. Through the VERTREP vertical replenishment mission, it uses a cargo hook under its belly with a 9,000-pound load limit to fly shuttles between supply ships and the carrier. From an engineering perspective, the Sierra is not just hoisting physical crates, it is hoisting operational tempo. It ensures the flow of ordnance is never interrupted, allowing the carrier to maintain continuous pressure without ever returning to port. But using 4,000 horsepower just to haul groceries is a waste of kinetic energy. In military thinking, a high payload platform equals a heavy weapons platform. The Navy decided to redefine the purpose of this void to switch from transporting life to delivering death. The transformation of the Sierra from a pack mule into the fleet's Swiss Army knife began with the quietest threat: sea mines. A $5,000 mine can disable a $13 billion carrier. Previously, the fleet had to wait for slow, wooden-hulled minesweepers. The Sierra changed the game by switching from acoustic physics to optical physics. Using the ALM-DS, airborne laser mine detection system, it flies near the surface at 100 knots and fires a green LiDAR laser into the sea. Light is faster than sound. The Sierra scans a wide area, generating a 3D map and classifying moored mines in real time. The moment a target is identified, it drops the AMNS, a fiber optically controlled expendable neutralizer. The operator flies this robot to the mine and detonates a shaped charge. This is organic capability. The fleet no longer needs a babysitter. They can clear their own path through a minefield immediately. But what if the threat rushes you on the surface? The next challenge is swarm attacks, dozens of suicide speedboats. The Romeo's torpedoes are too expensive. The ship's guns are too cumbersome. You need a solution that is cheap but precise. The Sierra Block 3 was surgically altered to add bat wings, stub wings that turn the cargo bay into a weapons rack. Their solution is the APKWS. The Navy took the dumb 2.75-inch Hydra rockets from the Vietnam era and gave them a brain and laser guidance seeker and control fins. It turns every cheap rocket into a sniper missile. The Sierra can pick off individual boats in the swarm from a safe distance. And if they get through that net, GIU-21. 50 caliber heavy machine guns in the windows are ready to speak at 1,100 rounds per minute. However, there is an asset even more valuable than ammunition: the human. We have talked about destroying the enemy, but a perfect war machine must protect its own core resources. In the cold calculation of the Navy, a human being, whether a $1 million pilot or a deck crew member, is an irreplaceable biological asset. As we noted, the ocean respects no rank. When a blue shirt is blown overboard or a pilot ejects, they face the same death sentence: thermodynamics. Their body is a 98-degree heat source, the ocean is an infinite heat sink. This energy differential will kill them in 15 minutes. Here, the physics of failure is revealed in inertia. A 100,000-ton aircraft carrier moving at high speed cannot just stop. It needs miles of ocean and 30 minutes to arrest its momentum and turn around. The mothership cannot stop to save its own child. It is too massive. It is too slow. To solve this, you need a vehicle that defeats inertia. You need the Sierra. The moment the man overboard alarm sounds, the Sierra switches roles from truck to ambulance instantly. It is the only vehicle that can reach the scene within the golden hour. The rescue hoist on its starboard side is a precision mechanical arm with 250 feet of steel cable and a 600-pound lift capacity. It snatches biological assets from the grip of death, whether it is an admiral or a recruit. But the Sierra's greatest value is not when an accident happens. It is when an accident has not happened. Every time the flight deck is active, there is a Sierra flying in circles at the plane guard position. Its presence is a psychological contract. Thousands of sailors dare to push their limits, running between searing jet exhausts on the edge of a slippery deck in the dark for one reason: they know the angel is hovering right above their heads. They know that if they fall, the Seahawk is coming. Without that sound of rotors, the morale of the entire fleet would collapse under the fear of a cold, lonely death. Modern warfare is not like the movies. It is not decided by individual bravery alone. It is decided by the perfection of the system, by logistics, by maintenance, by the placement of a wheel and the volume of an empty void. A carrier strike group is the ocean's apex predator, but unmatched physical power is meaningless if it is limited by the horizon. A blind giant can still be defeated by a dwarf with vision, the MH-60. Seahawk is the final piece of this projection. The Romeo provides the coordinates, the fleet provides the destruction. The Sierra pumps the blood of logistics, ensuring the giant's muscles never starve. This is the perfect symbiosis of steel and data. The next time you see an image of an American carrier, do not just be dazzled by the flashy jets, look for the rotors spinning tirelessly alongside them. That is what turns a powerful fleet into an invincible one.